in this direction. So my tension meter in the center is reading 19 newtons left to right. If I turn it this way, it's about 19 to 20. So the whole idea as I increase this tension is to be plus or minus 2 all the way up to where I want to be at a final tension. So this is an N166 Newman mesh. It's capable of going up to the mid-60s, okay? But we're putting it on a frame that tops at about 35 to 40. So we have different models of frames that handles different screen tensions. The mesh has no limitations. And what we'll do is, by what I see here, I would turn both of these. As I increase the air, the wrenches will start to move. And you'll see, I have to look at it, I'm sorry, I have to look at it right now as I do this, but you can see that the wrench starts to move. Therefore, tension starts to increase.
Is it okay to have the tension gauge on there while you're applying your pressure?
Yeah, you need to have it on there, otherwise you need to know where your tension is. And your corner softening, you also have to be keeping an eye on that, because the whole purpose of the corner softening is to allow the tension to build up in the center out. And as it does that, the corners start to tighten up. So the softening of the corner allows the tension from the center to start out. Okay, so now we're at about 24, 25 in both directions. I'm getting a little ambitious. Let's go a little higher.
Give it a good tug, huh?
Hopefully it doesn't rip.
Now, will
okay.
the micron count rip a screen quicker?
Micron, you know, it's very important that Lon touched on that. Thread micron is not only very important in knowing from a printing standpoint, but tensioning, because you can get a mesh count that's the same, but the thread microns are different. And it's very important that you know what you're getting, because if you just ask for a 166, and let's say, you know, you get it from here at 50 microns, and you go somewhere else and order a 166, and that happens to be 54 microns, it changes the whole dynamics of the printing result. But all you know is the same mesh count. And it also will change the tension capacity. It allows you to go higher. You know, if the thread micron's higher, the thread's thicker, you can go higher with that tension. So it's important to know all that information. So here we are at 28 in both directions. Okay. Now the other thing about our frames is that it'll be hard to see on the small one, but when you tighten these bolts or torque it all the way around, the rollers actually will bow outward. Okay, will bow out. And the reason for that is to compensate on the amount of deflection in. Because if you look down this frame right now at 2830 newtons, that's a lot of force. This frame is actually, the mesh is pulling the frame inward. But when I go to torque these bolts now, it'll push the roller out and minimize that inward deflection.
When you tighten, they're actually going to pull in.
The rollers are actually going to pull out. So what you'll notice is that this tension is going to jump anywhere from 4 to 6 newtons, because the rollers are going to push outward. Versus a frame that starts out straight. Yeah, you just, you know, once you know, and just becomes everything gets documented. So if you know you want to go to 30 and you know it jumps, you know, 4, then you stop short and allow for the 4 Newton increase. It won't hurt if you go over, but you just need to know what you're going to get. You know, if you see the results at 35 and you go, oh wow, that's incredible. I wonder what I'm going to get at 45. Well, now we have an M3. The M3 is our automatic frame. This can also be used as an automatic, but it's more of an oversized manual frame. Okay, this frame allows you to go up to 85. Believe it or not, mesh actually becomes stronger Roller mesh is already a strong mesh. What I mean by strong is, you can't, it's not going to withstand any sharp object. It's going to rip. But strong in the sense that it goes up to a higher tension. And mesh, whether it's roller mesh or conventional mesh, becomes stronger in the retensioning process. Okay? The problem is when you're using the stretch and glue frames, aluminum or wood, there is no retensioning process. You get it, and you may or may not know what that tension is, but when you get those screens, it's at its highest tension. When you start to use it and apply pressure through degreasing, reclaiming, and then printing, that tension drops and will continue to drop each time you use. That's where you start to see a lot of variables that Lon's been talking about. With the roller frame, it allows you to take it to whatever manufacturer's mesh says you can go to, or maybe perhaps where you think you're comfortable in your shop. But the whole idea is, if you're getting the end result is exactly what you want or your customers, we document everything: inks, mesh count, stencils, blah blah. But who documents mesh tension? I mean, that is a huge variable that creates everything else. So just pulling screens off a shelf, same mesh count, same image, same everything, but all of a sudden registration's not there, inks don't seem like they're as bright as they used to. Well, because when you first used it, it was at one tension level, and the second or third time, now it's at a lower tension level, and you're getting completely different results. So now you're blaming the ink manufacturer or the emulsion or the mesh, and you're changing all this stuff, but you're not addressing the screen's tension.
So now we can go to a higher standard now.
The roller frame allows you to go, if I'm at 28, I'm good there, that's what I want to be. I'm going to lock this up. Let's do that.
So you said if you're tightening right now, the screen's starting to pull out?
Once I torque it, I'm going to go around this twice. I'm just going to snug it, snug the bolts all the way around. So when it clicks, that's where you want to stop. Okay, I've torqued it, so what's happened here is the corners, when they're torqued, has forced the screen outward. And turn the air off. We were at 28, right? Now we're at 34.
It went higher?
Yeah, because it increases. Okay, so we got that 4 or so Newton jump. So the advantage now is that we both are able to get an initial tension much higher in a roller frame, but the advantage is that when you go to print with this, it's going to lose tension just like on the screens you're using now. But when it comes off the press, reclaim it, I'm going to put my meter back on it and go, well, it needs to be back at 32, but now I'm back at 25 or lower. So put it back on my table, put my wrenches back on here, loosen the bolts, and go back to 32. Tighten it back up.